Some people discover new things about the universe, but very few people give us an entirely new one to live in. Today, we're talking about one of those people, Sir Isaac Newton. And we're going to look at the three incredible keys he used to basically rewrite our understanding of reality itself.
So, to really get what Newton did, you have to understand what people thought before him. And honestly, they saw the cosmos as being completely split in two. Up there, you had the heavens, perfect, divine, running on celestial rules. And down here, well, you had Earth, messy, chaotic, and playing by a totally different, much grittier rulebook. They were literally two separate worlds.
And this is where Newton comes in. His first big revolutionary idea, to just smash that wall down. He had this wild notion that a single set of laws could govern everything, from the stars in the sky to the ground beneath our feet. And it all famously started with a pretty simple question. Now, to us, this might seem kind of obvious, but you have to realize just how radical this was at the time. To even think that a boring old apple falling from a tree had anything in common with the majestic moon in the sky, that was a mind-blowing leap of imagination.
And Newton's answer to that question was universal gravitation. He said, look, this pull isn't some mystical force. It's a fundamental property of the universe. Every single bit of stuff in the cosmos pulls on every other bit of stuff, and we can actually measure it.
Now, I know, an equation on the screen, but don't think of this as just math. This is like the source code for the universe. All it's really saying is that the pull between two objects depends on how massive they are and how far apart they are. That's it. And without one simple, elegant rule, the universe went from being this unknowable mystery to a puzzle that we could actually start to solve. And just look at what this single idea explained. Suddenly, all these things that seemed totally disconnected, they all clicked into place. The planets going around the sun, the moons circling us, even the tides coming in and out on the beach. It was all the same force, gravity. It was the ultimate aha moment for physics. This wasn't just a big deal for science. It changed philosophy. It changed everything. The universe was no longer seen as this stage for unpredictable drama. Instead, it became this incredible, intricate clock, a machine that once wound up just works, all on its own, following these perfect, predictable rules. So you'd think unifying the entire cosmos would be enough for one lifetime, right? Nope, not for Newton. For his second key, he turned his sights on another giant mystery, the very nature of light and color. He devised this absolutely brilliant experiment. So picture this. He's in a dark room. He lets just a tiny slit of sunlight in, and he sticks a prism in its path, and boom, you get a rainbow on the wall. Now, people had seen that before, but here's the genius part. He then took a second prism and used it to catch that rainbow, and showed that all those colors would merge right back into a single beam of pure white light. And what did that prove? Well, it meant that white light isn't pure at all. It's actually a mashup of all the other colors combined. The prism isn't making the rainbow, it's just unpacking it. The colors were hiding inside the white light the whole time. This completely overturned what everyone had believed for, forever. This discovery changes everything about how we literally see the world. That red shirt you might be wearing? It's not inherently red. It's just that the fabric is absorbing all the other colors from the light and bouncing the red part back to your eye. And because each color bends at its own unique angle, you can use this to analyze stuff. This was the birth of a whole new field we still use to figure out what distant stars are made of. Just amazing. Okay, so Newton has these brilliant laws for a universe that's always in motion. But there was a big problem. The math to actually describe a falling apple or an orbiting planet, it didn't exist yet. So what's a guy like Newton gonna do? Well, you invent a whole new kind of math. And that brings us to his third and maybe most powerful key. Yeah, think about it. The math they had back then was great for things that just sat still. How big is this triangle, or what's the area of this field? But the real world isn't static, is it? It's all about change and movement and flow. The old math just couldn't handle it. So he invented calculus. And this car analogy is the perfect way to get it. First, you have differential calculus. That's basically your car's speedometer. It answers the question, how fast am I going at this exact instant? Then you have integral calculus. That's your odometer. It adds up all those little moments to answer the question, how far have I gone in total? And make no mistake, calculus wasn't just an abstract exercise. It was the engine that powered the whole scientific revolution. For the very first time, we had a language that was powerful and precise enough to describe reality as it truly is, constantly in motion.
So let's just step back and put it all together. With these three keys, gravity, light, and calculus, Newton didn't just add a few new pages to our book of knowledge. He gave us a completely new blueprint for the entire universe. It really was a total transformation. Before Newton, you had a divided cosmos. After, a single, unified system. Before, you had vague ideas. After, you had precise mathematical laws. The world went from being a mysterious, unpredictable place to a knowable, predictable machine.
And that is the real core of his legacy. These three huge achievements weren't separate things. They all worked together. They built a brand new framework that lets us understand, predict, and even start to control the forces that shape our world.
You know, in the end, Newton's work is way more than just a bunch of brilliant theories. It's a powerful story about what the human brain is capable of when you mix that deep, relentless curiosity with a really strict, logical way of thinking about things.
And that brings us to one last question to leave you with. Newton gave us this beautiful, orderly, predictable universe that runs like a clock. But then, along came Einstein and quantum mechanics, which told us things are a lot weirder and fuzzier than that. So the question for us today is this: are we still living in Newton's universe? Something to think about. Thanks for joining me.